Alrighty, Earth Science, let's get into this. We are going to be talking about, well, you guessed it on the screen, the moon. So we're going to start talking about the phases and kind of how it affects our life here on Earth. Okay, let's do it. Okay, so I have a little setup here. We have this blue circle right here is the Earth. You are here. The moon is this grayish, kind of green tinted circle right here. I drew in numbers all the way around, and these yellow lines represent the sun being way out to the left, and the yellow lines represent the light coming from the sun, and it comes in pretty much parallel based off of the fact that it's so far away. And so what's going to happen is this moon is going to go in a circle around the Earth. It's going to revolve around the Earth. What I want you to do, well, this is not something I'm going to get your answer from, but it's just a way for you to get your Earth Science kind of thinking brain back on, is I want you to try and think which one of these numbers will be the location where the moon is a full moon. Which one of these numbers is a location where the moon is the full moon? Now notice that the center of the Earth circle, where's my cursor? There it is. The center of this Earth circle right here, that's the North Pole. And so you got to tell me, where is there a full moon? So as we go around, where is a full moon? And I just want you to think about it, because we're going to get into the moon's revolution and rotation. So the moon's orbit takes 27 and a third days to complete its full revolution around the Earth, just a little bit short of a month. That's why we call, like, a blue moon is something where you have two full moons in the matter of a month. It happens, well, not super frequently, but it does happen in terms of two full moons being that 27 and a third days away from each other, but within the same month. Now, the moon can sometimes be in the day sky. It's in the night sky when the moon is on the opposite side of the sun, and in the daytime sky when it's on the same side, or when it's in between the sun and the Earth's revolution. Okay? Here's the thing that's really peculiar about the moon's rotation and revolution, is that the revolution takes 27 and a third days, but the rotation also takes 27 and a third days. They are the exact same amount of time. So the amount of time that it spins on its own axis and the amount of times it revolves around the Earth is the exact same time, which means that there's one face of the moon that is always towards us. You've only ever seen one half of the moon with your own eyes as you look up in the sky, because the moon is sort of kind of turning and facing us all the way around as you're kind of going, or all the way as it goes around us. And so there's one half of the moon that we call the face that we see, the light side of the moon or the dark side of the moon if you're a Pink Floyd fan. And so this is kind of really interesting about the moon rotation and revolution, that you've only seen one half of it with your own eyes. So here we have another image very similar to the one that we just did with the where's the full moon. So if you imagine you on Earth, bam, whoa, there's you. And if you were to be looking at the moon, you will notice that there are areas where the moon is shaded, and there's areas where the moon is in the light. Now, in this case, we have the sunlight coming from the right side to the left, but you will notice that every single moon, check it out, every single moon has the light side on the same half. Each one of these, the light side is on the right half, which makes sense because the sunlight is coming from the right. Half of this moon is in the light, and it's always the face that is towards the sun. Now, if you were to think about your perspective of the moon right here, well, it would be really, really hard to see the moon in the night sky right here because, well, the side that's facing you is the side that is the shadow. And so when we look at this, we call this the new moon, because you actually will not be able to see the moon in the sky right here because, well, the entire side that is lit up, the entire side that is facing the sun, is not facing you. It's facing the opposite direction. And so as we start seeing this revolution, well, the light side of the moon is going to start creeping in from what you would consider as the right side. And so what we'll have is what we call a waxing crescent, where most of the moon that you can see is in a shadow on the left side, but we have a little bit of a kind of sneaking in of the light on the right side. And so that shape right here, this kind of moon-like shape, is what we would call a crescent. And waxing crescent just means that it's going to be growing as the first half kind of it goes through the first half of its revolution. So the next we would call the first quarter, which is a little interesting because half of the moon is being shown, but it's a quarter of the revolution. So notice that we've only gone a quarter of the way around this circle. And so it's the first quarter moon where the right side is lit up, but the left side is a shadow. You would guess that, well, now we have even more of the moon being shown, because now almost all of what you are seeing in terms of what side of the moon is facing you is the light side, and you have a little bit of a shadow here on the left. And so we have a little bit of a shadow here on the left, and most of it is light. If you were to guess where the full moon was, well, the full moon is on the opposite side of where the sunlight's coming in, because at this point on Earth, and so I'm showing you this, what you can see, well, the side that you could see at right here is the entire light side. And so right here, we have a full moon. So the full moon is on the complete polar opposite side as the new moon. So they're completely opposite. So notice that you'll see that we have a waxing crescent and a waxing gibbous. Now we are going to have what we call a waning gibbous. So now you can see a little bit of shadow growing in from the right side. So where in the waxing side you had a little bit of light growing off to the right, now you have some shadow coming in on the right side. Right here, if this is called new moon, this is called first quarter, full moon. This one is going to be called last quarter or third quarter, which is half of the moon being lit up, but now it's the other half of what you had in the first quarter. And last but not least, if you are following patterns, a follower of patterns, we had waxing crescent, waxing gibbous, waning gibbous. This is waning crescent. And so we have that last bit of light being shown off to the right, or off to the left. And so these little triangles are really, really, really great to draw right here, because it'll show you what amount of the moon is actually in your vision. So if we draw this little triangle, you'll see there's a little bit of light on the left and mostly shadow on the right in terms of your perspective. And so we have mostly shadow on the right and a little bit of light on the left. Now this is really challenging, and to be honest, I even contemplated showing you this because it can get a little confusing at home, or we're not like in school practicing this stuff together and going through that. Just know that these names you don't necessarily need to know. It is more about the full moon and new moon and kind of understanding that the light will always be on one half of the moon, whichever direction the sun is coming from, or the sunlight is coming from, and that can affect how much of the moon we can see. And so we have a little bit of special situations when the sun, moon, and Earth are in a complete line with each other. Now there's obviously two moons because we'll talk about it. It's the eclipses, and there are two different types of eclipses. So the first eclipse we're going to talk about is a lunar eclipse. So this is when the Earth, moon, and sun are in a line with each other, but the moon is in between the sun, or sorry, the Earth is in between the sun and the moon. And so this is where you can't see the moon because the Earth's shadow is blocking it. Where the sun's light comes in, but the Earth blocks the sunlight, and that moon sits in the Earth's shadow. And so we have something that looks like this. Something that looks like this. based off of, I mean, this is from a whole bunch of different stuff, but it can also be because of the bending light around the Earth. So if we look at this picture, so if that's the lunar eclipse right here, the solar eclipse is when the moon is in between the Earth and the sun. And so when the sun kind of is trying to give light off to the Earth in this half of the Earth should be daylight, but because the moon is in between, we have a shadow. And so this is what you saw in 2017 that looks like this, where the sun is being blocked by the moon. Now, not every aspect or not every location on Earth has what we would call a full eclipse, but a lot of places have a partial eclipse. So Plattsburgh had a partial eclipse, and this is kind of an image of what the eclipse looks like from outer space. And so you'll see that this whole side of the Earth should be in daytime, but we have a giant shadow here, and you would guess what is creating that giant shadow? Well, it's the moon. The moon is kind of in the way, and so everyone here has a full eclipse. And so we see all these different, just a large shadow cast by the moon on the Earth. Now, why doesn't this happen every day? Or every month, or every year even? It's because you don't get this kind of perfect alignment all the time. The Earth has a tilt, and so the moon, sun, and Earth system isn't always perfectly aligned where you get this nice shadow. Okay, so then the other thing that gets affected by the moon on Earth is our tides. And so we have 2 high tides and 2 low tides every day. And this is due to the fact that there's a gravitational pull of the moon and the sun. Now, the sun has a greater gravitational pull because it's larger, but the moon has a greater effect on tides and a greater gravitational effect on the tides because, well, it's closer. Sure, the sun is much, much more massive and has a higher, stronger gravitational pull, but it's so far away that it doesn't affect the tides as much as our moon does. And so we have what we would call a spring tide, where you see that the sun and the moon are kind of working together. They're both pulling the water this way. So we have these great high tides, like stretching the water on the Earth. So we have low tides here, but high tides here and here. Whole lot of water there. And then we have the opposite, which is the neap tides, which is where they're kind of fighting each other, where we have not as strong of tides anywhere because the moon is pulling the water in one direction and the sun is pulling it 90 degrees away from it. And so the moon and the sun are kind of fighting each other in that sense. And we have some pictures here so you can see how drastic this is, right? In this picture right here, the water line's way out here and we have all of this space that isn't touched by water. And then here in the high tide, we can have water that reaches all the way up to this line, which would have been all the way up to like here in this picture. It's kind of crazy. Here's another picture right here. And so you could see a man presumably standing in what I would imagine is the same spot, and you could see how drastic these high tides and low tides can be. And one last image. Once again, you could kind of see all that's being affected by these tides. You really don't want to get caught out here because, well, you can be in a whole lot of water really quickly. Alrighty, so that's our lesson for the week, and I will see you next week. See you guys later. Bye.